Hey everybody, Dr. Jonathan Hoover here, and we're getting this set of videos started on migrating from SPSS to Julius. And this video is on prompt engineering, which does not mean engineering on time. It means letting the AI system know what we want it to do with our prompts. And AI by default is pretty good at figuring that out. But in a special case like this, where we want stats done a certain way, the SPSS way, we have to give it some information so that the AI engine knows what it is that we're looking for. And there's a few ways that we can do that. One way is right here, I'm in what's called a thread. They also have workflows in Julius. I'll show you that in a minute. But if I'm in just a normal conversation thread, I could put my prompt engineering just in the chat and say, this is what I want you to do. That's what I'm going to do here in just a moment, and I'll show you how that works. I could also go up here to my settings, and I could go to customize Julius and enter some prompt engineering into this box that theoretically should always be considered whenever the notebook is running, or excuse me, the chat is running. But I find that sometimes it forgets what I put here. So I'm assuming it will get better as time goes on, but for right now, I don't rely on that a whole lot. So I'm going to show you how we can do it in the thread. And when I do a video on workflows, I'll show you how we can do it with workflows. There's a couple of options for how we can do it there as well. A couple of setup things. You want to make sure that the engine is set to R and not Python, which is what it will be set to by default. So Python is wonderful. I love Python. There's all kinds of wonderful things you can do with it. But after a lot of research for how to get SPSS accurate results, we need R because we need a certain programming library, which I'll show you in just a minute, called JMV. And JMV only runs in R, not in Python. Hopefully, maybe someday there's a Python version, but for right now, it just runs in R. The other thing is right here, you have what artificial intelligence engine you want to use. Many of us are familiar with ChatGPT. I'm going to encourage you to use Claude 3.5 Sonnet. I have the best results with that. Now, I will tell you that one thing to know is that Python is better at reading and writing SPSS datasets. I find that R is still a little clunky with writing SPSS. Reading it does fine, but writing SPSS datasets a little clunky. And in one of my videos, I'll show how to bridge that divide if you have to output an SPSS dataset in a couple of different ways. But for now, just be aware of that. So this is how I have it set up. I'm using the R engine. I'm using the Claude 3.5 Sonnet AI prompts. And now I'm going to do a little bit of prompt engineering. And I'm going to copy in a block of text of instructions that I've generated as I've worked with Julius to do things the way that I want it to do. And I'm just going to walk you through these things. You don't have to know what they are. I'm going to walk you through them anyway. I'm going to be providing the most recent block that I've written with this video, and it may change over time, but I'll try to provide that block as I change it. But I have these numbered because I find that the AI engine does better when it understands the individual, like where the break is between the instructions. The first one is I'm saying use JMV for statistical analysis whenever possible. What does that mean? Well, R and Python are programming languages. There are what are called libraries of code that have all of the functions. So if you think about Excel, you think about writing a function to do a certain task. It works the same way in computer programming. There are functions that do certain tasks. And so there are libraries of functions, and all these libraries have different names. And there is a library of functions called JMV, and it was written for a statistical analysis software called Jamovi. And Jamovi is basically a alternative to SPSS. You can download it. I'd highly recommend it. I'm a big fan of Jamovi. And it actually runs on an R backend. That's why it works here, is that Jamovi is basically just a graphical user interface for R, but it was built by the programmers to get the same results as SPSS so that it could be a substitute for SPSS. So here we're just basically skipping the graphical user interface of Jamovi, but we're using that backend to get the same results, which is why we want it to use JMV. There are default statistical packages that Julius would use otherwise, like CAR is a very common R statistical package. We do not want it to use that because we would get slightly different results with that, because again, it doesn't know how to run it exactly the way that SPSS is running it. Number two, at the end of each analysis block, report in bold font whether JMV was used. Here's the thing. Again, as I mentioned before, it writes new code every time you give it a prompt. So there's always the possibility that it might struggle to write that JMV code, and it might try to fall back to one of the other systems. I want to be able to know whether or not it used JMV. Because if it used JMV, I can be confident that I'm getting SPSS-style results. If it didn't use JMV, I probably need to rerun it again and remind it to use JMV. So I'm using this little prompt to make sure that I'm able to know when we might have a problem. When checking for outliers, use the IQR SPSS-style formula unless given other instructions. Frankly, I like to use z-scores as criteria for outliers, but SPSS by default uses an interquartile range calculation, and so I'm just reminding it to do that. Don't remove outliers unless instructed by the user. Some of these instructions I'm giving are based off of things that I experienced when I was experimenting. And one of the things that I experienced when I was experimenting was a couple of times Julius just, in order to try to help me, removed outliers without even, and it stated it. If I had read the output thoroughly, I would have seen that it removed the outliers, but I wasn't expecting it to, and I wasn't getting the right results. So I just want it to only do that if I tell it to do it. When ingesting data from SPSS, use Haven. That's the library of code. Just like JMV is a library, Haven is a library, and it's written in such a way that it does a great job of keeping track of all the nuances of an SPSS dataset. And then I tell it, create a separate data frame for the metadata for the variables. What is the metadata? Well, if I'm in SPSS and I go to my data here, under variable view, all of this is metadata. So I'm saying create, just as this is its own data frame. So when we talk about a data frame in Python or R, we're talking about rows and columns of data. And so SPSS has a data frame for the data, and then it has a data frame for the metadata. Basically, I'm just asking Julius to do the same kind of thing. And then I'm saying use that metadata to set variable types and to report category names, etc. And then I'm asking to make it persistent because I don't want it to have to regenerate that data frame a bunch of times. And again, that's just something based off of experience that I had when I was experimenting. Don't conduct statistical analysis unless the user asks for it. This is a big thing because if I ingest data and if I give it any kind of idea of what the model is, what my independent variables are, dependent variables or whatever, it's going to want to run that analysis for me, and I might not be ready for it to do it yet. So I'm telling it, don't run it until I tell you to. If the user states a model with an interaction term, don't test the other interaction terms other than the ones given. This statement actually might not be something that you want to include. You might take that out. Where I teach, we use this textbook, Advanced and Multivariate Statistical Methods by Mertler, Vanetta, and Lavinia. It is a condensed version of Tabachnik and Fidel. And when they show you how to run a custom model for homogeneity regression slopes, or even just doing your basic factorials, ANCOVA and ANOVA, that sort of thing, they only run one interaction term. And by default, in this software, in Julius, it's going to test all the interaction terms. And so I'm giving it this instruction, only run the interaction terms that I give you. But again, depending on what text you're teaching, that might not be relevant. I'm saying don't use CAR for F-test or homogeneity variance, use JMV instead. This is another way of reminding it I want to use JMV. When the user requests graphs, unless the user is specific, use your logic to consider the best possible graph for the request. So basically, I'm just saying, if the user is just giving you a descriptive of what they want, try to come up with the best graph. And I probably don't even need that instruction, but I got slightly better results with it, so I left it in. When encountering errors in JMV syntax, so I'm saying if you try to run a JMV analysis for me and there's an error, I'm saying keep attempting JMV, because what it will do normally is it'll attempt another couple of times with JMV, and then if that continues not to work, it'll just fall back to CAR or some other library. I would rather it keep working and learn what it's not doing right and keep working on the JMV. So that's the instruction I'm giving it there. When asked to report an APA-style results section, be sure to include the paragraph write-up with scientific notation and tables and graphs. When reporting independent samples t-test, report t-test student's test as equal variance is assumed and Welch's as equal variance not assumed. This is just a way of getting the output to look like it does in SPSS. Whenever possible, use a table from the formatable library for results. So formatable is a really great library for presenting table in a tabular format instead of in just plain text. And then where result values are less than 0.001, report in tables and output is less than 0.001. Elsewise, I'll get scientific notation. So I'll get the negative exponential notation if it's a really small value. So I'm going to go ahead and give that to the prompt, or go ahead and run that prompt. And it should just read all those instructions, and it should confirm for me that it's read it and that it's ready to go. By the way, while I'm doing this, I'm going to change this to light mode because I prefer light mode over dark mode. There we go. And notice I'm just getting basically it's letting me know that it sees what I've asked it to do. The other prompt engineering thing is I just wanted to say load JMV and formatable, because until I load these libraries, it doesn't have them. So it would normally, if, could I just skip all of what I'm doing here and still have it work? Probably. And, I would say good chance it would work, but there's more to go wrong. And additionally, when you're actually doing your analysis, it's going to go slower because it's having to figure out these extra steps. So I'm going to say load JMV and formatable, and in parentheses, I'm going to put already installed. And this is something that we need to thank the folks at Julius for, because JMV, if it wasn't already installed on the Julius computer, I could install it in this chat, but it takes 12 minutes. And so Julius and I work together. Julius pre-installed formatable and JMV so that it doesn't take forever. As a matter of fact, you'll see when I go ahead and say I want it to run this, it doesn't take it very long at all to load because they're already installed. Okay, says the packages are loaded and ready for analysis. Okay, now the next thing that I want to do, and this is the last part of prompt engineering, is I need to upload the JMV documentation. And I'm gonna pause my video here for a second because I'm just going to use this this paperclip here to attach that file, but I can't remember where I saved it on my file system, so I'm going to pause this while I get that pulled up. Okay, so I found that file. It's just jmv.pdf and easy to get online, or I can provide it. Then I'm just going to say review this entire documentation. And the reason I'm saying entire is because sometimes an AI engine will just look at the beginning of a document. I want to go through the whole thing. And I'm going to say for prompt engineering, because I want it to know it's for Julius' sake, not my sake. I don't need it to review the documentation for me. I want it to review the documentation for it. For JMV syntax, I want it to know how to write JMV. I'll probably think through easier ways to say all of this. This is my current workflow, and so I'll let it do it. Now this will take a second because it has to upload this PDF, and the way that this system works, it will create a text file from the PDF, and then it'll analyze it. So I'm gonna press pause while it does that, and I'll be right back. While it's doing that, one other thing, you can see the stop sign here instead of the play sign. That tells me it's still working, and I appreciate that on the thread level. The workflow level, it works a little different to see whether it's still working or whether it is finished working. But here I can assume that it's still in the process of processing because I see the stop sign and not the play sign. Now it's telling me that it has reviewed the documentation, it knows the different proper functions and parameters, and it's ready to go. So this is my routine for prompt engineering. And I could name this thread and I could come back to it later if I wanted to, but right now I pretty much do it at the beginning of every thread. I'll also show you how you can do this differently with workflows. And I'm going to try to do in this series of videos how to do all the different kinds of analysis that I'm going to show you how to do, both in a thread, doing it using a thread versus using it doing a workflow. But in the next video, we'll talk about how to get descriptive statistics using JMV. So I'll see you then.